let us work with the sample exercises that involves the usage of engineering features what we have discussed so far. Now I have a geometry, the drawing of a geometry, which you can see on the screen. So this particular component, if we are observing, as I've already mentioned to you many a times, to observe the geometry what you're having, observe the drawing what you're having for a certain amount of time and understand what are the different components, features and tools that can be utilized for creating this particular drawing. So I have this drawing of a component, and on closer observation we may notice that this is a rectangular component. We have two sections, section A and section B. We also have a presence of a rib, which is the trajectory rib. You can see in the vertical form there is a rib, and in the horizontal form as well. Apart from this, we also have a presence of hole in the center, which can be seen with the help of a section B or section BB. So you can see a hole of certain amount of diameter, which is exactly in the center of the geometry. If we are looking at the geometry from the bottom view, particularly at the section AA, you can see that it is having a wall thickness of 6 units. We have the height, we have the width of the base, and apart from that we also have certain amount of rounded feature at the edges of the base. Not only that, we can also observe an amount of draft involved over here. The draft can also be observed from the top view as well. So the line what I'm highlighting now is the base of the total geometry. So this particular line is the base, and the outer line what I'm highlighting right now, or moving my cursor on the line right now, is the expanded form of drafted geometry. I mean, this particular edge is the outer edge of the top view, of the front view. From the side view we can observe that the trajectory rib is having a certain amount of height as well. It can also be observed in the sectional view, and this height is lower than the wall height. So it is certain amount of dimensions are used for lowering it. I mean, we can see that there is 20 units of distance or difference between the rib and the total wall. Apart from that, we also have a draft angle for the rib as well. So the angle of draft is 6 degrees. The draft for the outer wall can be noticed or observed in the right side view, which is equal to 25 degrees. So let us start creating this geometry and see how we can finish it. I will be attaching this geometry, this drawing in the resource. You may download and you may practice along with me. So I'll just minimize it and I will open the Creo. So similar to previous exercises, I have divided the screen into two portions. The left side is with the drawing layout, and I have also hidden the model tree so that we can have a very clear look on the screen. And on the right hand side, I will minimize the sketch of the geometry or the drawing, and let us start working with it. So I have the plane with me. So one thing you may notice over here that when I'm pressing Ctrl D, the default orientation of the plane is a little bit different as seen in the earlier cases. So what's happening over here is I have changed the setting of the display right now. So in order to get back to the default or the previous type of view, we can go to options, and under options we have a sub option called as model display, and here the first orientation was selected to isometric right now. So in the earlier case it was trimetric. I'll change back to trimetric and I will click apply and press OK and save the file. Now you can see that the orientation has come back to its original form, and right now we can easily start creating the geometry. So it's totally dependent on the user. We can also keep the default view as isometric, but I prefer it to keep in trimetric. Now where shall we start with the geometry with? That is the question what we are having right now. So let us try to create the overall geometry. I mean the total box we can create first. Then we can utilize the shell command and remove the top surface. And we can assign the thickness of the wall equal to 6 units. And after that we can create the rib. And then we can create the settings of, we can utilize the different settings of the rib and create the rounded feature or the draft, whatever we are having. And after that we can create the hole and finish the geometry. So let us try to create the first total geometry, the total box what we have. So what are the dimensions of the box, or what are the dimensions of the component? We have the width of the geometry in this particular view, and the width is equal to 350 units, and the dimensions are mm right now. So the width is 350 mm. The height or the thickness of the component is 100 units or 100 mm, and the length of the component is seen in the right hand side view, which is equal to 500 units. So I need to create a cuboid first, which is having a base of 350 by 100, and I can extrude it for a length of 500 units, or I can create a rectangle of 500 by 350 and create an extrusion depth. So totally dependent on us. So right now I will be selecting this as the front view because it is already written over here, and I will be working with the front view. So I will be selecting the front plane. I'll go to extrude, align my view, and create a center rectangle with the dimensions as per the drawing. So we have a width of 350 units. I've entered the width, and I need to enter the total length of the geometry. It is 500 units. So I have created the length and the width. I'll press OK right now. I'll go to symmetric because I want the geometry to be symmetry, and the depth is seen in the bottom view, which is equal to 100 units. And I will press OK right now. So we have created the raw material with us. I mean, we can just assume it as raw material. So we have to perform certain options on this geometry, and we have to convert it into that as per the drawing. So let us move to the next video and complete the remaining tasks.